Our world is in constant motion. I mean, think about it. From the sugar dissolving in your coffee this morning to maybe milk that's gone a little bit sour in the fridge, change is happening literally all around us, all the time. But here's the thing, not all of these changes are the same. They're actually governed by two really fundamental principles, and it all boils down to one simple question.
Why is it that you can refreeze water, but you can't unburn a match? Seriously, think about that for a second. You can take ice, melt it into water, and then pop it right back in the freezer to make ice again. It's a complete round trip, no problem. But a match, once you burn it, that's it. It's a one-way street to a little piece of char. So what is going on here? What's the fundamental difference?
And right here, you can see that puzzle in action. On one side, you've got that brilliant, permanent, irreversible change, that fire. And on the other, you have a substance that can just, change its state and then change right back. This is the absolute heart of the mystery. And to solve it, we've got to start by looking at the first type of change.
All right, first up, physical changes. This is the kind of change that lets you get your ice cube back.
So, what is a physical change? Well, the most important thing to remember is this. No new substance gets created. All you're doing is changing the physical properties, things like the shape, the size, maybe the color, or its state, whether it's a solid, a liquid, or a gas. But deep down, at its core, the material is still the exact same stuff it started as. A perfect example is just a piece of paper, right? You can cut it, you can rip it, you can shred it into 1,000 tiny little pieces. You've definitely changed its size and its shape. But what do you have when you're done? You just have a pile of smaller pieces of paper. Nothing new was made. It's still paper.
And this kind of thing is happening everywhere you look. When ice melts, it turns into liquid water, but it's still H2O. When that water boils, it turns into steam, but guess what? It's still H2O. You take a piece of chalk, crush it into dust, you haven't created anything new. You've just made, chalk dust.
And here it is. This is the key that unlocks that first part of our big mystery. Most of the time, physical changes are reversible. You can freeze that water right back into ice. You can cool that steam down and condense it back into water. That ability to go back and forth, that's the telltale sign of a physical change.
Okay, so that's one side of the coin. But what about those permanent changes? What about those one-way streets, like our poor burnt match? Well, that brings us to the second type of transformation, the chemical change.
Now this is a whole different ballgame. With a chemical change, we're not just talking about changing how something looks, we're talking about a fundamental transformation of the substance itself. The original stuff literally gets used up to create one or more entirely new substances. In that whole process, that's what we call a chemical reaction. And a perfect everyday example of this is just rust. We've all seen it. You leave an iron bike or a tool out in the rain, and it gets that flaky reddish-brown coating on it. Now, that coating isn't just wet iron or discolored iron. It is a completely new substance called iron oxide. We just call it rust. The original iron is gone, chemically transformed into something else.
Okay, look at this because you can actually see the chemical change happening right before your eyes. On the left, you start with that bright blue liquid, that's copper sulfate solution. But then you drop an iron blade into it and bam, a reaction kicks off. The solution turns green. Why? Because a brand new substance, iron sulfate, has just been created. And that brownish stuff coating the blade, that's pure copper, another new substance that wasn't there before.
Or how about this incredible reaction? When you burn a simple ribbon of magnesium, it flares up with this absolutely dazzling white light. It's super bright. But what's left behind when the light fades? It's not that shiny metal ribbon anymore. It's this white, powdery ash, a totally new substance called magnesium oxide. And there's no way you are not turning that ash back into a magnesium ribbon. That change is permanent.
So, the big question is, how can you tell if one of these amazing chemical transformations is actually happening? Well, lucky for us, there's some classic clues to look for. Think of this as your own personal chemical detective's toolkit.
All right, here are the top 5 clues you need to keep an eye out for. First is heat or light being produced. Think back to that burning magnesium. That's a big one. Second, do you hear a sound? Like a fizzing or a popping sound? Think about dropping an Alka-Seltzer tablet in water. Third, is there a new smell? Like when food goes bad? That's a chemical change. Fourth, a color change, just like we saw in that copper sulfate experiment. And finally, are bubbles forming? That's a sign that a gas is being created. If you spot any of these, chances are you're looking at a chemical change in action.
Okay, so we can tell the difference between physical and chemical changes. That's great. But so what? Why does any of this actually matter? Well, it turns out that understanding, and more importantly, controlling chemical changes is one of the most powerful tools we have as humans.
You see, chemical changes are kind of like a double-edged sword. On the one side, you have the destructive power. Just take rusting, for example. It causes billions of dollars in damage every single year, destroying bridges, ships, and cars. But on the other side, you have creation. Chemical reactions are the reason we have modern life as we know it. Every new medicine you take, all the plastics we use, the detergents that clean our clothes, all of it is thanks to us mastering these chemical changes.
And it's not just about stuff out there in the world. It's happening inside you right now. You are basically a walking, talking bundle of chemical reactions. When you digest your food, that's a whole chain of chemical changes turning that food into energy. A banana ripening on the counter, the photosynthesis in plants that makes the very oxygen we breathe. It's all chemistry, all the time.